Similar to linear inequalities with quadratic, you're going to make the greater than or less than sign, you're going to treat it like it's 0. So in this case, let's say if I were to rewrite it as 0, can you try and solve that for me, please? So when you factorized, should get x plus 1 in brackets, x minus 5 in brackets. Okay, that means x equals minus 1 and x equals 5. So if you were to draw a quadratic, it would look something like this, where that's minus 1 and that's 5. In our original question, it says our function, so our quadratic, is greater than 0. This is the value of y. So your y is 0. Y is 0 at the x-axis. So it's basically saying your function is greater than 0, or y equals 0. So you are focusing on that red part and that red part. Does that make sense? Because that's the portion of your graph greater than 0. Now, what you're essentially doing is you're looking at all the values of 5, or you're looking at 5 and greater. You're looking at minus 1 and below. So your inequalities would be x is greater than 5 or x is less than minus 1. Does that make sense? Cool. Let's say if theoretically it was less than 0. In this case, you would be looking at all the values under the x-axis, under y equals 0. In that case, it would be from minus 1 to the right and 5 to the left. So greater than minus 1 and less than 5. If you were looking below 0. Does that make sense? I hope so. Right, so have a look at that question for A. Find the set of values of x for which 12 plus 4x is greater than x squared. We want to rearrange that so we have a quadratic and we have 0. I want my x squared to always be positive because it's just easier to work with that way. So x squared minus 4x minus 12 is less than 0. Like we did before, make that equal to 0 and then solve. So can you try that? Make it equal to 0 and then solve it. You should have gotten x equals minus 2 and x equals 6 because your brackets would have been that. So when we draw it, minus 2 is here, 6 is there. In our question, is our function, or are we looking at our function below 0 or above 0? We're looking below 0. So we're looking at all of this, which means from minus 2 above and 6 below. So x is greater than minus 2, x is less than 6. We can put them together because remember, that, or notice that the arrows are going towards each other. So minus 2x and then 6. Does that make sense? I hope so. In part B, hence find the set of values for which blah 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 and 5x minus 3 are greater than 2. Let's solve this one. 5x minus 3 is greater than 2. So x is greater than 1. Cool? If we were to draw on a number line, we've got minus 2, we've got 1, we've got 6. So we're going to have everything greater than this, and then everything between minus 2 and 6. The inequality that includes both of those, let's say, rules is 1 is less than x, which is less than 6. We're looking at the bit where it overlaps. That's what satisfies both inequalities. Does that make sense? So in that scenario, you're just looking at overlap to find the solutions of both inequalities. Okay. Have a look at question 6 and question 7 for me. I want you to give those a go, please. So, you are going to solve x squared minus 5x minus 14 equals 0. And when you do that, your two brackets are x minus 7 and x plus 2, and that's going to be greater than 0. So x equals 7, x equals minus 2. You draw it, minus 2, 7. You're looking above 0. So you're going to highlight from 7 and up, minus 2 and up. So from 7 onwards and from minus 2 backwards. So the inequality or inequalities which satisfy that are x is greater than 7 and x is less than minus 2. Because the arrows are going away from each other, we can't combine them. They stay separate. So x is less than minus 2 or x is greater than 7. Cool. 7a. You're going to expand 6x minus 2 is less than 4 minus 2x. So 9x is less than 8. X is less than, sorry, not 8, 6. X is less than 2 over 3. Cool. 2x squared minus 5x minus 3 is less than 0. Minus 5x minus 3 is less than 0. You factorize that, and when you do, you get 2x plus 1 and x minus 3 is less than 0. So that means x is equal to minus a half, x is equal to 3. You draw minus a half, 3, less than 0, meaning you are highlighting the portion underneath the axis, from minus a half and up, from 3 and below. So x is greater than minus a half, x is less than 3. Arrows are going towards each other, so you can combine minus a half less than x, which is less than 3. Okay, That's part A done. That's part B done. Both 2, 3x minus 1 less than 4 minus 3x and the quadratic. So you are going to do your number line. We're going to have 2/3 here, minus a half here, and 3 there. So we're going from 2/3 and below, and we're going between a half and 3. We're going to look at the overlap, which is there and there. It's between the two, minus a half, less than x, less than 2/3. That's the inequality which satisfies both of them. And there you go. That is how you do quadratic inequalities.